All right, moose, cats, lemurs, people in Saskatchewan. Hard to say. Saskatoon, Saskatchewan. S sub t. The population, thousands of people, at time t is described by this differential equation. So I'm looking at the very first page, which is the front for you, and I see this, and it corresponds to this, or the, which one is it? It's neither. And I want to point out something. That 3p there, yeah, that doesn't happen. So something's kind of off a little bit. We need to fix something. So we're going to go ahead and just change this a little bit. And that P is in the way. I think, personal opinion, I like this one the most because L is staring you in the face. It is kind of here too, but for me, just this one seems so logical. So L for logical. I'm going to just make it equal. Almost drew an arrow. Let's make it equal. What I really want in parentheses is that, which means I'm going to have to factor out a 3. So let's factor out a 3. 1350 divided by 3 is 450. And that gives me a 3 there. And then I still have the P, and then 0.018. And then at this point, you can just kind of leave it here and talk about the fact that you know L, which actually answers this first question. If you want to get technical, though, you can do 0.018 times 3. I'm embarrassed that I'm typing that in the calculator. I sort of knew what it was, but a little tired. 0.054 P, and then 450 minus P. So this, factor the 3 out, put it there. So we've kind of changed the value of K based on the structure of the formula, but the idea remains. So here we go. As we approach infinity, as time moves forward, time approaches infinity, what is the population of Saskatoon, Saskatchewan? 450. That's it. Now, that may not be accurate. I think I might have made these numbers up. But anyway, 450 people, not much. When does the population grow the fastest? Oh, when is the rate of change of the population at a maximum? At half of the carrying capacity. We've been through this. So that would give me 225 people. When is the population of the graph concave downward? Okay, so you know what the graph looks like. Here we go. We've got this. Oh, let's draw it. Switch colors here. Concave down right here. Well, where is here? Now, I may not know the time for this, and so I think the question could be better worded with something like, for what populations is the graph concave downward? And it would be for populations that are greater than half of the carrying capacity and technically less than the carrying capacity. So in between L over 2 and L. So we're going to just basically say it's for populations greater than the carrying capacity. So concave down, the graph is concave down for populations that are greater than half of the carrying capacity, 225.